All right, so moving on to page 3. So this is 8.2, page 3. Last page of this section. So we know how to describe the sampling distribution of p hat now, and in particular what we've discovered is that under certain conditions p hat is going to be normally distributed. And that's good news for us, because that means that we can use the normal calculator in StatCrunch to compute probabilities involving p hat. So again, we see the normal distribution coming into play here, right? So it's a very important distribution in statistics. So let's look at a couple examples. Okay, so number 4 here says, according to the National Center for Health Statistics, 15% of all Americans have hearing trouble. In a random sample of 120 Americans, what is the probability that at most 12% have hearing trouble? Okay. So the population proportion of people who have hearing trouble is 15%. So if you went out and randomly selected 120 Americans, what's the probability that at most 12% would have hearing trouble? So 12% or less. It's probably a pretty small probability, but let's see. Okay. So we know that under certain conditions, p hat is going to be normally distributed. In particular, we should check to make sure that n times p times q is bigger than or equal to 10. Let's see. So our sample size was 120. Our population proportion was 15%. Q is 1 minus p, right? So if p is 15%, that would mean that q would have to be 85%. Okay, we want to know if this is bigger than or equal to 10. Let's see. 120 times 0.15 times 0.85 is 15.3. That's definitely bigger than or equal to 10. So we're going to say, so p hat is normally distributed. That tells us that we can use the normal calculator in StatCrunch to compute this probability that we're being asked for, right? So we're going to go to Stat, Calculators, Normal. When we get there, they're going to prompt us to enter something for the mean. We should enter mu sub p hat for the mean. Mu sub p hat happens to be the same thing as the population proportion p, which we've already said was 0.15, right? We're also going to be prompted to enter something for the standard deviation. For the standard deviation, we should enter sigma sub p hat. We have a formula for that, right? Sigma sub p hat is the same thing as the square root of p times q over n. Okay, so for sigma sub p hat, we're going to enter square root of p times q divided by n. So that would be 0.15 times 0.85 divided by n is 120 in this case, right? So divided by 120. Let's see how much that is. So we have square root 0.15 times 0.85 divided by 120. Rounding to 2 decimal places, maybe I'll go 3. I'll go 3 decimal places. So to 3 decimal places, this is 0.033. Okay. So once we've entered, so we're going to go to the normal calculator. We're going to enter this for the mean. We're going to enter this for the standard deviation. And then once we've done that, we can compute the probability that they're asking us for. They're asking us for the probability that p hat is at most 12%. At most, that would mean 12% or less, right? If the most it can be is 12%, then that means p hat has to be 12% or smaller. So we're going to say probability p hat is less than or equal to 12%, right? 0.12. Let's go to StatCrunch and see what this is. So we go to Stat, Calculators, Normal. We're going to put in, for the mean, we said we would put in 0.15. For the standard deviation, we said we would put in 0.033. And we're looking for the probability that p hat is less than or equal to 0.12. Okay, and there it is. That's about 0.1817. That's that. So there you go, right? So if you know that 15% of the population has hearing trouble, then the probability that you would get a sample where only 12% of people have hearing trouble is that probability is 18%. It's a little more than 18%, right? So there's a little more than an 18% chance that you would get a sample with such a small proportion of people having hearing trouble. Okay, that's a small-ish probability. It's not terribly small. We wouldn't call it unusual, that's for sure. Okay, so that's that one. Let's look at Part B. Okay, so Part B says, suppose that a random sample of 120 Americans who regularly listen to music using headphones results in 26 having hearing trouble. What might you conclude? Okay, so here they're asking us to perform some inference, right? Here they're asking us to extrapolate a little bit. So, so we have a random sample of 120 Americans. 26 of them have hearing trouble. Oh, these particular people in this particular sample listen to music using headphones. Well, one thing that I might be interested in knowing is, what is this sample proportion, right? So what is the sample proportion here? Right, that would be 26 out of 120. 26 out of 120 is about 0.217 if I round it to 3 decimal places. So 0.217. Well, that is larger than average, right? It's like we would have expected 15% to have hearing trouble in our sample. We got 21.7%. So the question is that unusual? Is it unusual to get a sample proportion of 21.7 or more if the population proportion is 15%, right? So would this be an unusual thing to happen? Well, to answer that question, we can compute the probability, right? We're going to compute the probability that we get 0.217 or more. And if that probability is really small, then yeah, this is an unusual thing. And we might be able to make some conclusion based off of that. So let's go ahead and compute this. We've already checked the condition. We know that p hat is normally distributed. So we can go ahead and use the normal calculator. And in fact, all of this work that we've done in Part A, it still relates to Part B, right? The mean is still going to be 15%. The standard deviation is still going to be 15% times 85% divided by 120, and take the square root. So all of that stuff is still the same. But this time, we're going to look at the probability that p hat would be greater than or equal to 0.217. We want to see if this is a strange thing to have happened. So let's take a look. Okay, so I'm using the same normal calculator as before. This time I want the probability that p hat is greater than or equal to 0.217. Okay, so there's that probability. Oh, to 4 decimal places. So to 4 decimal places, that would be 0.0212. Okay, so that's unusual, right? The probability that we would end up with a sample proportion that's so large is, less than 5%. There's less than a 5% chance of that happening. So this is definitely unusual. I would say something like this. Maybe I would say this probability is less than 5%. So p hat equals 0.217 is unusual. It's unusual for sure. So then the question is, well, what might you conclude from that, right? So we ended up with this unusual result. Big deal. Who cares, right? Well, think about the scenario, right? What's different about our sample here is that we took a random sample of 120 Americans who regularly listen to music using headphones. That's what's different about our sample, okay? When they gave us 15% up here, they were just talking about all Americans. They were just saying 15% of Americans have hearing trouble, right? But now if we restrict our attention to people when I restrict our attention to Americans who regularly listen to music using headphones, suddenly the proportion of people with hearing trouble jumps up to 21.7%. Well, so what can you conclude from that? You can conclude that hearing trouble is linked to headphone use, right? Which is not all that surprising, right? If you're listening to headphones, especially at a high volume, you're more likely to develop hearing trouble, right? Of course, this is an observational. This would be like an observational study, right? So you can't necessarily conclude cause and effect. But you could say that there's a link for sure. You can say there's a correlation. You can say there's a correlation between headphone use and hearing trouble for sure. So you might, at this point, if you were researching this problem, then you might want to set up some kind of designed experiment to figure out if there is in fact a causal relationship. And I think it's fairly obvious that there probably is, right? But anyway, so what might we conclude? We can say, well, we conclude that headphone use is linked to hearing loss. Okay, and that's that. Okay. So that's why we want to be able to compute probabilities involving p hat. At this point, let me just say we've been using the normal We've used the normal calculator for 3 different things. Okay, we use the normal calculator to compute probabilities of just a single event happening from a normal population. We've used the normal calculator to compute the probability that the sample mean of a bunch of observations is some particular value. Okay, and then now we're using the normal calculator again, the normal distribution, to compute probabilities involving the sample proportion. Okay, so my advice to you would be to go through your notes from 7.2, 8.1, and 8.2 and really do your best to try to differentiate between those 3 usages of the normal calculator, okay? I'll tell you the main difference in the way that you use them is what you enter for the mean and the standard deviation in those three types of problems. So go through your notes and try to really distinguish between those three things. But that's it for 8.2. There's your homework assignment. I will talk to you again soon.